So this is going to be a strange video on my channel because it's directed just as much to wrestling fans as it is to people looking for help on math. I've got, three total conversation killers in my life. I'm a retired math professor. That will stop a conversation in its tracks at a party. One of my favorite forms of entertainment is pro wrestling. That will stop many conversations cold at a party. And I also like heavy metal, which it doesn't quite stop all the conversations, but it certainly doesn't get a whole lot of them started either. So being a math professor with an interest in wrestling, I was fiddling on Reddit, and I browse the Squared Circle subreddit fairly frequently these days, and there was a thread about AEW's Continental Classic tournament, and I just made an offhand comment in the thread about cool math problems that might come out of the tournament structure that they've set up. And so I decided, I'm gonna pull that thread and see what happens. So this is my first attempt at having a little bit of fun. If you like wrestling and you're curious about math, this is not going to be deep math. It's just going to be some easy counting principles, but we're going to have a little fun with it, I think. So I've called this We Want Tables because the graphic for the Continental Classic is a table. So we're going to talk about the round robin structure and just some of the number stuff that can be extracted out of it. So this is the way All Elite Wrestling's Continental Classic works for people that don't know what that is. You can watch the programs that they have on Wednesdays, Fridays, and Saturdays. And currently, as of the posting of this video, they've been doing this Continental Classic tournament for, I guess, a couple of weeks. And it's probably going to continue for several more. So what this is it's a round robin tournament. And they have 12 wrestlers that they've chosen to be in this tournament. They've split them into two groups of 6, and then with each group of 6, it's a round robin structure. So everybody in the 6 wrestles everyone else. You get 3 points for a win. If you tie, like a time limit draw, you each get a point, and once the two groupings are resolved to a winner, those two winners are going to face each other for the grand prize, whatever the heck that is. Maybe it's like an old Lincoln Continental, something like that. Okay, so there, when you think about that, you've got some number questions that are popping up. Like, okay, there's two groups of 6, but everybody has to wrestle everybody else because it's round robin, but there's two groups, and how many matches are there going to be altogether? And then once you figure that out in math, the big thing is just to ask, well, what if? What if we used a different number of wrestlers? How hard is it to crank out a new total number of matches that are going to have to take place? What if you split the wrestlers up into 3 groups instead of 2? All right, so this is the way it looks as is. A badly drawn table, right? So let's say in one group, say the blue group or the gold group, I don't care which, there's 6 wrestlers in it, and the results are going to be put into this table, this array, or matrix, if you like to call it that. This will help us figure out how many matches there are going to be. Now, the answer isn't going to be 36 because wrestlers don't wrestle themselves, unless you're like, I don't know, maybe Santino did that at some point. I don't know. But let's say wrestler 1 takes on wrestler 3 in this group, and wrestler 1 wins. That means a 3 is going to go in wrestler 1's column, and then when 1 is wrestling 3, 3 is also wrestling 1, right? So 3 would get a 0 because he lost, okay? And I don't know if this is exactly how they're doing it, but the point is that any one match that takes place ends up getting recorded in 2 boxes in this grid. So if wrestler 5 takes on wrestler 4, that's going to be recorded in this box and in this box. Okay, so we have to fill up the whole table in order for the tournament to be done. So the number of matches that have to take place is just the number of boxes that are above this diagonal row of red X's, which precludes wrestler 1 from facing wrestler 1. Once we've filled up all the empty boxes on the top half, we also have filled all the boxes on the bottom half, or vice versa. So to figure out how many matches you need with 6 people in the group, we're just going to count those boxes. So where's my diagram here? So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. I already put a check there, and 15. Okay. Is there a pattern to this? Because if we want to change the number of wrestlers in a group, how hard is it to update that number? And there is definitely a pattern. It's very visual. When I counted from the top down, but watch what happens when I count from the bottom up, right? So right here is the first empty square when it's a fresh grid, right? Forget the checks and the 0s and 3s. So this is the first empty grid from the bottom up. So there's 1, then we go up to the next row and now there's 2, go up to the next row and now there's 3, and then 4, and then 5. So how many matches are there? 1 plus 2 plus 3 plus 4 plus 5. Okay. Now there are 6 wrestlers in this grouping. So take 1 away from that, because we're not going to use the bottom box, right? And add up all the numbers, the integers that come before that. So that's basically the pattern. 6 people are in the group. 1 plus 2 plus 3 plus 4 plus 5 is the number of matches that you're going to have. And so, if we open that up to not just 6 people in the group, but whatever number there is, if there's 8 people in this round, that counting is going to make us go 1 plus 2 plus 3 plus 4 all the way up to plus 7, right? So n people are in the group, 1 plus 2 plus 3, etc., all the way up to that number minus 1. That total sum is how many matches that are going to be in that round. So if we go back and just, try that again for 2, 3, and 4, just to make sure we got it. If I go back to my table here, if we want a tournament with only 2 people in it, I'm not going to use red anymore. We just have to carve out that little box, right? If there's only 2 people in it, and we go up from the lowest right-hand corner, there we go. That's the only box we have to fill, because there's only 2 people. They're only going to have 1 match, right? So that works. 1. Not even 1 plus something, just 1. But now let's take it up to a tournament of 3 people. Okay, well, now in order to fill this grid, we need to put scores in this box, and this box to be done. 1 plus 2. Okay, take it up to a tournament, little grouping of 4. Well, 1 plus 2 plus 1, 2, 3. Okay, and then you're done. So 6 matches, right? And that's how we ended up getting 15, because for this grouping of 6 people, right, 1 plus 2 plus 3 plus 4 plus 5, that got us up to the 16. Okay, so there's how you count the number of matches. But that could be tedious, because, like, what if we just wanted to be silly and put 15 people in a group? Okay, well, then to figure out the number of matches, 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7, all the way up to plus 14. Who the hell wants to sit there and add up all those numbers? So is there a better way to do that? And the answer is yes. It turns out that in math, there's a really simple formula that gives you a shortcut to doing this addition. If you want to add 1 plus 2 plus 3 plus 4 plus 5 plus 6, all the way up to plus 98, to get the number that would yield, you do 98 times 99 divided by 2. Right? That is a much easier calculation than adding all these numbers. Right? Unless you're in Excel and you could just spool a column down to a grand total. Okay? Originally, I was going to demonstrate why this formula works, but I was going to take too long with this dumb thing anyway, so I decided not to do that. But if I do a next video, maybe I'll squeeze that in. It depends if I'm looking for ways to waste my time and yours, if I'll do another one. Okay. Now, for our purposes, say we have n people in the grouping, like 6 people in the grouping, we just want to add up to 5, right? To n minus 1. So I've adapted this summation formula to the way we're going to use it, that with 6 people in a group, we add up to 5, 1 less. And so what used to be n times n plus 1 is n minus 1 times n over 2. And then for n equals 6, that's 5 times 6 over 2. 5 times 3, 15. And that's the number we already knew, right? And then for that 15 person group that we didn't want to sit there and adding up all the numbers up to 14, well, now we just calculate that total by 14 times 15 over 2. Boom, that's 105. So that's how many matches it would take to put 15 people in one of these round robin grids and have it run all the way through. 105 matches. Now, the full tournament isn't just the one grid. It's two groupings, the blue and the gold. So you're gonna finish up one grouping, you're gonna finish up the other grouping, and then the winners of each of these two grouping tournaments are gonna face each other for the championship. So having figured out how many matches are in any one grouping, you gotta double that for both, and then add one more match for the big prize. So if M is the number of matches in either group, they're going to be the same. Then the total number of matches overall, I've called it T for total because, you know, I'm clever that way. That's 2M plus 1. So again, for the original tournament as is, there's two groups of 6 each. We already figured out that one group requires 15 matches in order to finish out. So 2 of those plus 1 more for the overall winner, 31 matches altogether. So they're going to be broadcasting 31 matches in order to complete this Continental Classic tournament. Okay? That other silly example where we sort of, what if we wanted 15 people in a group? Well, the total number of matches you would have to do to finish out that tournament, 105 for each grid. We already counted that, 105 and 105. So 2 of those plus the 1 more to finish it out, 211 matches to finish the Continental Classic if there were 15 wrestlers in each group. Okay? So let's just go hog wild, right? This is where it gets fun. Let's say that AEW has 60 wrestlers on their roster and they're going to throw all of them into this tournament. Okay? They'll keep the same structure. They're still going to break them into 2 groups. And we're going to figure out how many weeks of television is it going to take to finish this out. So there's 60 people split into 2 groups, and we're going to air it on Dynamite, Rampage, and Collision. Nothing else is going to be aired on these shows except interviews and people booing Don Callis, right? So Dynamite's 2 hours, Rampage 1 hour, Collision 2 hours. So 5 hours of television per week, and let's say that they can air 4 matches per hour. So in a week, they can show 20 matches. So to have a tournament that's going to take all 60 of their wrestlers, and again, that's a number I've just made up because it's nice and round, 20 matches per week, how many weeks is it going to take to complete the entire tournament? All right. 60 people split into 2 groups. That's 30 participants per group. And as we've done multiple times, the number of matches to finish out the group is just 1 plus 2 plus 3 all the way up to plus 29, which by our shortcut, that's 29 times 30 over 2. And that turns out to be 435. That's just in one group, right? So we got to double that because there's 2 groups and then have an extra match to determine the overall winner, 871 matches. By the way, I did this while I was watching old Mission Impossible reruns, so surely there are mistakes in here, probably serious ones, and also maybe just small calculation errors. Yeah, I'm just having fun. If you see a mistake, I can't fix it, but you know, put one in a comment, I guess, so other people aren't fooled by it. But yeah, so 871 matches to finish out that full tournament that had 60 people in it altogether. How many weeks is that? Well, 20 matches per week to cover 871 matches. That's 43 weeks and change, so let's just call that 44 weeks. It would take almost a full year of broadcasting nothing but Continental Classic matches to finish out a tournament just like the one they have if they had 60 people in it instead of 12. Okay? But back to that theme, in math you like to ask, what if? What if, you know, it takes 44, well, this isn't the what if, right? We just discovered that if you take the wrestlers at 60, okay, that's our made up number, split it into 2 groups, it takes 44 weeks to finish the tournament. You know, what if they just all got lumped into one group instead? Don't split them into 2, just one big group. Would that just double the number of weeks that it takes to cover the tournament? Because when you split them into two groups, all the people over here are not wrestling any of the people over here, except in the possible very final match. Okay, but if we just put them all into one group, now everybody has to wrestle everybody, all 60. Would that just double the amount of weeks it takes? Okay, well, we know how to count this now. One big fat group of 60, the number of matches, 1 plus 2 plus 3 plus 4, all the way up to 59. So that total is calculated in a shortcut by 59 times 60 divided by 2, and that is 1,770 matches. And that comes out to be, with rounding, 88 weeks. So yeah, it does. But here's the other big what if. Well, what if instead of 2 groups, we split them up into 4 groups? So we're going to take the 60 wrestlers, we're going to split them into 4 groups. So group 1, 2, 3, and 4. Each of those is going to be a little mini round robin tournament. And then the 4 winners that come out of those are going to have their own teeny tiny round robin tournament to determine one overall winner. All right, let's run those numbers. So a group of 15 would require 14 times 15 divided by 2 matches to finish that one round. That's 105 matches in any one of those 4 groupings, right? So 4 of those, 105 per group, 4 groups, that's 420 matches to resolve the groups. I live in Indiana, so I can only say nice about this, in general. The 4 winners then would only have a mini tournament. We know how to count how many matches that takes. That even wouldn't be tricky. You could just think that through. That's going to take 6 matches, or with 4 people in a little mini tournament, 3 times 4 divided by 2. 6 matches to get that final winner. So you got 420 to resolve the groups, 6 more to figure out the winners of the winners, 426 matches. And that would take about 22 weeks of television. So what's the best setup, right? Obviously, there's pros and cons. If you're trying to get all this stuff into as small a TV window as possible, what can you do, right? Because now we're coming up with, it's still 60 people, but depending on how you arrange them, it takes different numbers of weeks to finish the tournament based on the groupings. Okay, so what do you do? Well, let's just ask that question. Well, let's say we don't have in mind a particular number of groups in advance. We're just going to call that number G for groups because, again, I'm clever. And we're going to figure out how that number G affects the time it takes or the number of matches that have to be done all together. All right. So, but hold up, because if we have 60 wrestlers, we can't just pick any number of the groups, right? We want to be able to split them evenly. We don't want to take 60 wrestlers and split them into 13 groups, because that's not going to be an even division and one of the groups is going to be out of whack, right? So we have to make sure the groups are of equal size, and that means if there's 60 wrestlers and we're going to split them up into groups, we can only break them up into groups that are counts of the factors of G60, okay? So like if, we took our 60 wrestlers and broke them into 5 groups, well, that's 12 wrestlers per group, right? Because 5 is a factor of 60 and its co-partner number there is 15. So we'd have to have groups of 2 groups of 30, 3 groups of 20, 4 groups of 15, right? There's a limited number of groups, and we could have 30 groups of 2. That would be silly, probably, but we're gonna see if there's a magic way to set this up. Okay, so let's put this all together. So we're going to take, I'm going to say any number of groups, but there's an almost that because we're only going to think about factors of 60, okay, for this experiment. Well, if we take 60 wrestlers and divide them into G groups, the number of wrestlers per group is 60 over G, right? Take 60 wrestlers, divide them into 4 groups. That's 60 over 4, 15 wrestlers per group, okay? See, everybody takes math. I say, when am I going to do this in real life? This is where it all comes, okay, to count wrestling matches. Aren't you glad you studied? Now, the way we did that before is the way we're going to do it now, right? Whatever number that we're interested in, it's that number minus 1 times that number over 2. That counts up the number of matches that we need to have to finish out that grouping. So the number of wrestlers is now 60 divided by G. So that number minus 1 times that number all divided by 2. That's how many matches per group. But there are G groups. Okay, so I've cleaned this up a bit. It's this expression right here, just kind of accordioned out a bit. The 1/2 is yanked out to the front, and I'm multiplying by the number of groups, right? So this number times G, and then some cosmetic cleanup. That gets us this mess right here. That's the number of matches altogether in all the groups, okay? But one person elevates out of each of these groups, and then all those winners themselves go into a little mini round robin tournament, so that there is only one. There can be only one out of this, okay? But we know how to count that. G of these winners put into a round robin grouping of their own, G minus 1 times G over 2. That's how many extra matches there are. So altogether, whoops, no equal sign there. I didn't notice that before, and I am not about to re-record this to go back and put an equal sign. So right there should be an equal sign. The total number of matches required to clean up and resolve a winner, where we take our 60 and divide them into G groups, is this monstrosity right here. So it looks ugly, but now you can do some, now it looks better. You can do some number experimentation. So the nice factored version of this function is right here, but if you like it multiplied out, there you go. So what I did was I said, okay, 2 groups. Now we already calculated that earlier, but if we use this formula, we still come back with that 871 that we saw before, right? Suppose we take our 60 and split them up into 3 groups. It's going to take 573 matches to resolve a winner. Split them up into 10 groups, 195 matches. Split them, it looks like it's just going down, down, down. But here, when we get to, if we take 60 people, split them up into 15 groups of 4 each, that sounds a little weird, but who cares? That would also require 195 matches to resolve everything to a winner. And if we took 60 groups, and 60 wrestlers, and split them up into 20 groups of 3 people each, again, silly, but who cares? It would require 250 matches to get winners from each of those 20 groups, and then take all those 20 winners and put them in a big round robin tournament to resolve the final winner, 250. So you see these numbers go down, 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 but then back up again. That's interesting, because that means that there's some kind of minimum number of matches that we can get away with. So if you're trying to monitor TV time, is that minimum somewhere that doesn't make the tournament just completely silly, right? To squeeze this whole tournament into as small amount of a time window as you can. That's interesting. I also mentioned that, this function right here is just gross, but it turns out that when you put integers into it, you get integers back, even though the denominator depends on the number you plug in. That's pretty cool. Like this, if you plug in an integer, the ones we're dealing with, you're guaranteed to get an integer back from this, and not something weird like 37/4. That's pretty cool. So where does this function provide a minimum? Now, you calculus students are like, oh my God, he's going to do derivatives. I am not going to do derivatives. So if you're in calculus, if you've taken calculus, you know how to go to this function and figure out where its minimum value is. We're just going to take the easy way out and look at the graph. Here is the graph of that function. So this is really tiny for you, I know, but the horizontal axis down here, there's markers at 5, 10, 15, and 20. So that's the number of groups we're splitting our 60 wrestlers into. And this is the value of the function on that curve. So you can see that the total number of matches required to resolve one winner by splitting your 60 and putting it into like 5 groups, there's the value. 10 groups, there's the value. 15 groups, there's the value. And it's right hair below 200, and we calculated that at what, 195? And then it goes back up again. So right here is where that number hits the minimum. That's at 12. Okay, so the math tells us that the ideal scenario, if we're trying to conserve television time for this thing, is to split our 60 wrestlers into 12 groups. Now that means you're taking 60 wrestlers, splitting them into groups of 5. Each of those groups does a round robin tournament that would itself take 1 plus 2 plus 3 plus 4. 1 plus 2 plus this, 10 matches to resolve. And then those 12 winners just get piled into one big round robin bracket to finish it out. That's how you can get away with resolving this winner out of 60 wrestlers in the minimum amount of television time by doing 100 and what was it, 120. Did I even calculate that number? I didn't calculate the actual number. What a dope. Okay, but it's whatever this value is. So it's going to be a hair less than 195. Like right about there. Let's just say it's 170. Here, I know. Evaluate this function for x equals 12. There you go. 186 matches is the minimum you can get away with. And how many weeks of TV time is that? Well, divide that by 20. So 90 plus change. 20 plus change. So, no, 9. 186 divided by 20. 20 matches per week. So we need 186 matches to get done. 20 of those a week can go on TV. So that's 9 plus change weeks. We'll call it 10 weeks. That's the best we're going to be able to do with this tournament structure. And that was specifically tying to 60 people in the tournament. So what if we just want to pick, maybe 5 people are hurt, so there's 55 people. That reduces the number of groupings you can do, of course. Or maybe you hired more people, or maybe you made it an intergender turn. I don't know, whatever it is. Let's say we opened up the number of contestants to 90. What would be the way to run the tournament to conserve the most amount of TV time? Well, all I did is I went back and replaced the 60s with this W, which would be the number of wrestlers, W for wrestlers, because I'm clever. This would be it. So you could tinker with this function. You could put in different numbers of wrestlers and also different numbers of groupings and calculate how many matches it would take to resolve one winner out of this parachute structure, where you start with the groupings and then the winners of those parachute into the final tournament to resolve the ultimate winner. Okay, and I'm not going to do anything with that. So when I first thought about this, I started thinking about other questions like, okay, winners get 3 points and ties get 1 point. So like in this tournament, 6x6 grids for now, what's the smallest number of points you can get and come away with the win? All right. What's the largest number of points you can have but still lose? Questions like that. Now, I haven't thought about those at all. I don't know if they're easy to think about or not, but if I do decide to think about them, maybe I will do another one of these. I hope this was fun. I had fun doing it, obviously, or I wouldn't have made it this far. I appreciate you watching this. I have other videos on my channel that are just more generic how-to math videos from pre-calc, calculus, linear algebra, stuff like that. So if you like it, browse. I am on the radio in my hometown. Not that's not a big deal. I'm not saying I'm a big radio personality. It's a local nonprofit radio station. It's called WVLP, right? We're all volunteers. I do a heavy metal show, 2 hours, Wednesday nights at 10 and Sunday nights at 8. These are Central Time. You can stream it on the TuneIn Radio app or by going to wvlp.org, and there's a little Listen Now button. So if you like heavy metal, I invite you to come listen to the show. Again, that's Wednesdays at 10 p.m. Central or Sundays at 8. Maybe you'll hear something that you like. I tend to play newer stuff because it gets delivered to us by the marketing folks. And I throw in oddballs as well. The other thing I do is I have an occasional show, like once or twice a month, depending on how many shows are around. It's called the Northwest Indiana Wrestling Action Program. I take my gear and I go do audio coverage of local independent wrestling shows. I record them. They're not live broadcasts. I record audio while I'm there, and then I kind of edit it and trim it down to about a 1 hour or less broadcast, which takes you through the whole show, highlights of the matches, who won, who cracked who over the head with a chair, things like that, for several local independent organizations. And I appreciate them allowing me to come in and entertain myself and hopefully other people that listen to it. Those you can find, you can listen to them on the radio if you want. They follow Mostly Metal on the weeks that I have them, but I also put them on YouTube afterwards. Now, that's a whole different channel. This is my Metal Prof channel, the Metal Professor's Math Coaching, that channel for all my math videos. The other one that has the wrestling videos is NWI Rap, NWIWRAP, Northwest Indiana Wrestling Action Program. If I had it to do all over again, I would have made up a name with a better acronym, but I'm stuck with it at this point. So go look for that YouTube channel, and you can dial up some of this coverage of local wrestling events. And I've been yapping for half an hour. If you're still with it, thanks for listening. I had fun. I hope you had fun. Math rocks, wrestling rocks, and you put them together, and it can be a good time.